Alright, now we're going to do a basic risk analysis of Shrieves, this Shrieves investment project. We've already calculated the cash flows associated with this project. You can go and see that other YouTube video where I calculate the cash flows if you'd like to. In any case, we have a model where we have some inputs, and I've highlighted in yellow some of the inputs that we're going to look at in the risk analysis. So we have some inputs. Those inputs are tied into the calculations here for this model. And we have in this model a final calculation that gives a net present value based on those inputs. And what we'd like to know right now is what happens if our assumptions, our underlying assumptions about this project are a little bit off. Specifically, we'd like to see what happens to the net present value if the discount rate is a little bit different from what you thought it was going to be, if the number of initial sales or total sales each year is a little bit different from what you thought it was going to be, and also what happens if the salvage value is different from what you thought it was going to be. And this is going to be what we call a sensitivity analysis. We're going to analyze how sensitive the net present value calculation is to changes in the discount rate, in the unit sales, and in the salvage value. And we'll actually plot those on a graph as well. Now what I've done is I've created the beginnings of a data table, and I'm going to go ahead and delete this right now so you can see how to construct it yourself. What we're going to do is we're going to create a data table in which the discount rate, the weighted average cost of capital, varies from a base case, which we started off with 10% in the last video, and we're going to decrease it by 15% to give 8.5%, and decrease it by another 15% for a total of 30% reduction to get a 7% discount rate. Similarly, we're going to increase the discount rate by 15% and then by a total of 30%. We're going to do the same percentages for sales and for salvage value. So unit sales started off at 1250, and notice in this cell I've got the number 1250 typed, and this cell I've got the number 10% typed. I'm not referring to any of the parameter section cells in this. This is just a list of numbers that I want to have. And this will vary by 15% lower from 1250, by 30% lower, and then 15% higher and 30% higher. Similarly, the salvage value started off at $25,000, and we'll vary it down by 15 and 30, and then up by 15 and 30 as well. Now, for those of you who don't know, the way that we create a data table is first thing you do is you put in the numbers, and what are we going to do? Ultimately, we'd like for those discount rates to get plugged back into our model where we have weighted average cost of capital, and I'll highlight that in yellow as well so that you can see. We're going to ultimately tell the data table to plug those numbers for discount rate into cell B14 and reevaluate what is in the net present value cell, which is B50. Alright, so let's go ahead and do that. We're going to, up in the upper right hand corner of our data table, we're going to refer to the net present value cell. That's going to be our output, and now we highlight the numbers that we want to go into the formula and the region below the net present value cell, our output value, and we click on somewhere data, and if I had a bigger screen, this would say what if analysis. Instead, it's just the spreadsheet with a question mark, and that is what if analysis. We're going to click on data table, and notice our data happens to be in a column, and so we're going to ignore the row input cell, and we're going to scroll on up to weighted average cost of capital, because that's where we want those numbers to go, and click on that cell for the column input cell. Click OK, and what happens is that Excel reevaluates that complicated model up there for different discount rates. And notice at our base case we got $88,000 and $88,010, which is what we expected, and then we got different NPVs for different discount rates. And the numbers make sense. A lower discount rate gives us a higher NPV. Now we're going to do the same thing with unit sales. And unit sales are going to get plugged into 1250. That's how many units we're selling every year. So we're going to put in a cell reference pointing to NPV right there, and then we're going to highlight it, what if analysis, data table, column input cell, point to weighted average, not weighted average cost of capital, sales, click OK. And this fills in the values for different unit sales. Finally, for salvage value, we're going to do the same thing. We have an NPV cell, and now we highlight the whole area. What if analysis, data table, column input cell, and this is going to go where salvage value was, and salvage value was somewhere up here in cell B8. Press OK, and that gives us a sensitivity analysis for discount rate, sensitivity analysis for unit sales, and a sensitivity analysis for salvage value. Now let's go ahead and graph these on a graph, and probably the easiest way to do that is to have what we're going to put on the x-axis, which is -30%, -15%, so that's what we use for reductions there, 0%, 15%, and 30%. And we'd like some of these numbers. We would like our NPV for all of those possible deviations from the base case. And let's just go ahead and say that, put in a cell reference pointing to what that is. And then we want a column that has the deviations from unit sales, and that would be the 16,000 all the way down to the $159,000. And then finally, we'd like salvage value, and we'd like to record all of those numbers. You don't have to do it this way, but I tell you, when I create graphs, I find it so much easier to just put everything in the in one column, where we have things that are going to go on the x-axis in the left-hand column and things that are going to go in the y-axis, the various variables, in columns over to the right, along with names to these things. And so now we'll just highlight them, and we'll do insert, and we're going to do a type of chart. We're going to always, in finance, you always do a scatter plot. You never do a line plot. Always do a scatter plot. And so we'll do a scatter plot with some lines on it. Let's do it like this, scatter plot with lines on it. And notice, since we had titles on this, the nice thing is that it has labeled everything for us. We have one line that shows what happens if we, yes, that's right, one line that shows what happens if we deviate unit sales by -30%, -15%, 0, and 15 and 30, and then other lines for the discount rate and the salvage value. And the steep lines are the ones that are very sensitive to a certain amount of deviation from the base case, and the ones that are really shallow are the ones that are not very sensitive. So in this case, the salvage value, the NPV is not very sensitive to salvage value. NPV is very sensitive, however, to the number of units sold every year, as you might expect. And consequently, what that means is that if you're trying to decide what information is really important to get, how much you ought to do some what information you ought to do extra research on, that would be unit sales and probably not salvage value, because the NPV is so sensitive to unit sales. And you also notice that under reasonable deviations, we still have a positive NPV, and so consequently, our accept-reject decision is probably not very sensitive to, is not all that sensitive to unit sales. We're going to do this project no matter what. Now, the problem with this type of sensitivity analysis is that it doesn't. Actually, you know what? We're going to stop right there, and we'll do the scenario analysis in the next video, because this is 9 minutes and 23 seconds. So, next video will be a scenario analysis.